Hi everyone, it's Miss Costa here, and in this video I'm going to be walking you through the Edexcel Paper 3 for the higher tier of November 2021. Okay, so in this question we've got a scatter graph question, and it's asking us to first of all identify the outlier. So an outlier is literally just a piece of data that does not fit with the general trend of the rest of the data. So it's going to be a point that's far away from everything else. So hopefully you can see that this one here is really far out from the general trend of the data. So write down the coordinates of the point. That would be 118. Then it says, for another day, 370 cars passed the point on the road. Estimate the carbon monoxide level for this day. Now, what a lot of people do is they're like, oh, okay, 370, I'm going to go there and roughly just plot a point. And that's like a common mistake people make. But when you're estimating using a scatter graph, what you want to do is draw a line of best fit. Okay, that's how you estimate. And to draw a line of best fit, you just draw a line that goes through as much of the data as possible. Ideally, you're going to have as many points above the line as below the line. And that's all a line of best fit is. Now, once you've drawn that, that is then how you estimate. So it says 370 cars passed. So we go to 370, which is here. And then we go up to the line. So start from 370 up to the line, and then we go across. So that's going to be roughly, now obviously my pen is thicker than the line should be. So it's not quite 13. So I'm going to say, well, maybe it is 13. Okay, let's just go for 13. But the point is that depending on your line of best fit, any answer in the range of 12.8 to 14.8 would be fine. So the important thing is you draw your line of best fit, and that's how you estimate. Okay, so as long as you've got that, you should get the marks. Alfie says, because there is an outlier, there is no correlation. Is Alfie correct? Now, all correlation means is that there's a relationship between the X and the Y axis. So in this case, the X axis is the volume of traffic and the Y axis is the carbon monoxide level. So is there a relationship between the traffic, the amount of traffic, and the amount of carbon monoxide in the air? Well, yeah, the larger the number of the cars, the higher the level of carbon monoxide. So there's a positive correlation in this graph. Okay, so positive correlation is when the two variables are positively correlated. So as one increases, so does the other. So we can see that there's a clear positive correlation. So we can say, no, he is incorrect, because we can see there's a clear positive correlation. The general trend of the data is going up, and one outlier does not affect the rest of the data. So to summarize what I just said, if you just say no, obviously you need to say whether he's correct or not. So you need to say no, and there is a clear positive correlation, and that's how you do that. So for this question, we're dealing with ratio. We're told that Natalie makes potato cakes in a restaurant. She mixes potato, cheese, and onion. So what helps is if we actually write out what is being mixed. In the ratio 9 to 2 to 1. So what I can do is actually visually represent that. So 1, 2, 3, 4, 5, 6, 7, 8, 9 to 2 parts to 1 part. Okay, so for every 9 parts of potato, there's 2 parts of cheese and 1 part of onion. Natalie needs to make 6,000 grams of potato cakes. Okay, so we know that we need to make 6,000 grams. So we use that to help us figure out how many grams of each ingredient we need. So if 6,000 grams is the total of these parts, what I need to do is 6,000 divided by 9 plus 2 plus 1 is 12. So 6,000 divided by 12 is 500. Okay, so each part is worth 500 grams. So what I can do is write 500, 500, 500 in each little part to show what it represents, and therefore work out the total amount of ingredients needed. So here I do 9 times 500, which should be 9 times 500 4,500. Here I do 2 times 500, which is 1,000. And this is just 500 grams. So that is the weight of all of the ingredients needed. So cheese costs £2.25, and we need to, for 175 grams, and we need to work out the cost of the cheese needed to make 6,000 grams of potato cakes. Well, it's cheese that I'm dealing with, so that's over here. So I need 1,000 grams of cheese. So I could do 1,000 divided by 175, which means I need 1,000 divided by 175, 5.714285 lots of this. Now, normally they might say cheese costs £2.25 for a bag weighing 175 grams. So if they said a specific bag, then you need to round it up, because you can't get 5.7 bags from a store. If you went to Tesco and you were like, oh, hi, can I have 5.7 of those bags? They'd be like, no, you buy 5 or 6. So normally you'd have to round it up. But in this case, it just says for 175 grams. So you could just buy it by the gram. So 5.714285 lots of this. So we do 5.7 blah, blah, blah times by £2.25, which gives us £12. So 5.7142 times by £2.25 is £12.857142. So obviously you'd round that to the nearest penny, £12.86. But if you did kind of round it up to 6, you would still be fine, because an answer in the range of 12.85 to 13.5 would get you the mark, so long as you've shown the relevant working. So that's how we do that. Okay, so this question deals with standard form, and all standard form is a way of writing really large numbers and really small numbers in a standard set way, so that we can compare them easily. So over here it's saying write 4.5 times 10 to the power 5 as an ordinary number. Now an ordinary number just means a normal number without any kind of to the power of. So let's think about this. So 4.5, if I multiplied it by 10, and multiplying by 10 is the same as 10 to the power of 1, that would be 45. 4.5 times 10 squared, that's 100, that would be 450. 4.5 times 10 cubed, that's 1,000, that would be 4,500. 4.5 times 10 to the power 4, that would be 45,000. Okay, so as the power increases by 1, it's multiplying that number by 10 again. So 4.5 times 10 to the power 5 is going to be, and the little trick here is I want you to understand why it's getting larger and larger and how you can work it out for yourself. But the trick is that if it's a positive, so 10 to the power of 5, you just have 5 digits after your first initial number. So you've got 5, that's 1, and then 1, 2, 3, 4, 5. Okay, so that would be 450,000. So you write your number, and there's 1, 2, 3, 4, 5 digits after the first number. But ideally, if you find this tricky, then just have a go at trying to visualize what it would look like. With each power of 10, you're multiplying by 10. Write 0.007 in standard form. So once again, let's have a look at what's happening. So if I did 7 divided by 10, and when I say 10 to the power of minus 1, what that means is dividing by 10. Okay, so multiplying by a tenth or dividing by 10. 10 to the power of minus 2, that would be dividing by 100. 10 to the power of minus 3, that would be dividing by 1,000. Okay, so 7 divided by 10 would be 0.7. 7 divided by 100 would be 0.07. And 7 divided by 1,000 is 0.007. So in standard form, that would be 7 times 10 to the power of 1, 2, 3, negative 3. So hopefully you can see that if you multiplied 0.07 by 1,000, it would get you to 7. So we have to do the reverse. And the cheat way is you look at how many, so you count the 0 in front of the decimal. So that's 1, 2, 3. So how many digits there are before your number starts. So that would be 7 times 10 to the power of -3. Then we have to work out 4.2 times 10 cubed. So that's 1,000. So that would be 1, 2, 3 digits. So remember 1, 2, 3. Plus 5.3 times 10 squared. So 10 squared is 100. So that would be 530. That's 2 digits. So whatever the power is, that's how many digits you have after your number. So 4,200 plus 530 is 4,730. And I need to write this in standard form. So the thing about standard form is it needs to be a number between 1 and like 9.9 times by 10 to the power of something. Okay, so it needs to be a number less than 10. It needs to be a single like digit number, but it can be a decimal. And it needs to be larger than 1 and between 9.9999. So I'm going to write that as 4.73. Okay, I've just turned it into a single, like it needs to be a single digit before the decimal place. And then I need to multiply that by 10 to the power of 1, 2, 3. I need to multiply that by 1,000 because that is equivalent. Yeah, 4,730 is 4.73 times 10 cubed. Okay, so a rate of change question. We are told that a water tank is empty and Anil needs to fill the tank with 2,400 litres of water. There are two companies that are being compared and they both supply the water at a different rate. We know that company A would take more time to fill the tank than company B, and we need to work out how much more time. So company A supplies the water at a rate of 8 litres in 1 minute and 40 seconds. So 8 litres is filled in 1 minute is 60, 40 seconds is 100 seconds. And we need to work out how long it would take to fill out 2,400 litres. So we do 2,400 divided by 8, which is 300. Okay, so we know that 8 times by 300 would give us 2,400. So what we have to do is multiply this by 300 as well. So 100 times by 300 is 30,000 seconds. So company A takes 30,000 seconds and 30,000, we want to turn that into minutes. So 30,000 divided by 60 is 500 minutes. Okay, remember there's 60 seconds in a minute. 1 minute is 60 seconds. Now company B, this is where it gets a bit tricky because we need to convert gallons and blah, blah, blah. So company B supplies water at a rate of 2.2 gallons per minute. So let's turn 2.2 gallons into litres. So put 2.2 gallons into litres. Now we know, actually let's do it this way. We know that 1 gallon is 4.54 litres. So 2.2 gallons, we multiply 1 by 2.2 to get to 2.2. So we're going to have to do the same to this side. So 4.54 times by 2.2 is 9.988 litres. Okay, so company B does 9.988 litres in per minute, so that's 60 seconds. We want to figure out how long it takes to fill up 2,400 litres. So we do 2,400 divided by 9.988, which is 240.288346. So we multiply this side as well by 240.288. And that gives us, oh, big number, 14,417.30076 seconds. Actually, we didn't need to do that because we're doing it in minutes. So let's divide that by 60, and that takes me 240.28 8 minutes. Okay, so company B, 240 minutes, company A, 500 minutes. So how much longer, how much more time? All I need to do is 500 take 240.288, which leaves me with 259.711. So it says give your answer in minutes correct to the nearest minute. So that would be 260 minutes. So here I've got a Fibonacci sequence, and Fibonacci sequences are really fun. So all a Fibonacci sequence is it means that the term is made up of the previous two terms. So the third term here is made up by doing A plus 2A, which is obviously 3A. The next term over here, that's made up by doing the previous two terms. So 2A plus 3A is 5A. Okay, so that's all a Fibonacci sequence is. It's the sum of the previous two terms is how you get the next term. So we are given the first 4 terms, okay? And it says the sum of the first 5 terms is 228. So we're going to need to work out the 5th term. How do we work that out? We add the previous 2 terms. So 3A plus 5A is 8A. So the 5th term is 8A, okay? So we know that the sum of these is 228. So let's write an equation. So A plus 2A plus 3A plus 5A plus 8A is 228. Remember, sum just means total. So adding. Okay. So let's simplify this. So 8 plus 5 is 13, 16, 17, 18, 19. So that's 19A is 228. So to solve that, we're going to divide both sides by 19 to figure out what A is. And 228 divided by 19 is 12. So A is 12. So here I've got a probability table. Now the key thing about probability tables and with probability in general, it always sums to 1. Okay, so that's the key thing. Now we're told that there are only red, blue, green and pink counters, and a counter is going to be taken at random from the bag. The table shows the probabilities of taking a red or a blue counter, so that's already given. And we're told that the probability of taking a green counter is 0.2 more than the probability of taking a pink counter. So we know that the sum of this needs to add to 1. So 0.05 plus 0.15 is 0.2, which means that 1 takes 0.2 is 0.8. Okay, so green and pink must add up to 0.8. Now, we know that the probability of taking a green counter is 0.2 more than the probability of taking a pink counter. So let's say green is X. No, let's say pink is X. Green would be whatever pink is plus 0.2. Okay, so this is pink. This is green. Now, whenever we don't know the value, remember we always use algebra. So here we've got x plus 0.2 must equal 0.8. So let's simplify this equation. 2x plus 0.2 is 0.8. So 2x is 0.6 and x is 0.3. So that means that pink would be 0.3 and green would be 0.3 plus 0.2, which is 0.5. So that's. And next we're told that there are 18 blue counters in the bag. And we know that 18 is 0.15 of the probability. So that's easily divisible by 3, as is 18. So 0.15 is worth 18 counters. So that means that 0.05 is 6 counters. Okay, how many lots of 0.05 are there? Well, 5 goes into 120 times. So if you multiplied that by 20 and you multiplied this by 20, 1 would be 120. So there are 120 counters in the bag. Okay, so in this question, we're dealing with circles, circle parts like sectors and segments. So we're told that we're showing a sector of a circle, and it's clear by the 90-degree angle that it's a quarter of a circle because, well, it is. There's a circle is not 360 degrees. 4 lots of 90 is 360. Center O and radius 8 centimeters. OPR is a triangle, and what's important about this triangle is it's made up of 2 radii, so therefore it's an isosceles triangle because it has 2 equal sides. So if it has 2 equal sides, it means it's got 2 equal angles as well. I don't actually know if that's going to be relevant to the question because I haven't finished reading it, but just a little side note. So what we need to do is work out the area of the shaded segment and give our answer correct to 3 significant figures. Okay, so the first thing we're going to need to do is work out the area of the triangle. Oh, why is that pen doing that? So the area of the triangle and the area of the sector. Okay, so the area of the triangle and the area of the sector. This is what we do whenever we have like any shaded parts. So let's say you had this big rectangle here, and you needed to work out the area of the garden minus the pond. What you do is you'd work out the area of the rectangle, subtract the area of the circle to work out the area of the pond. So that's exactly what we're going to do here. Work out the area of the whole sector, so this whole thing here, and subtract the area of the triangle. Now, it's a quarter of a circle, so all I'm going to need to do is, what's the formula for the area of a circle? Is pi times radius squared. And it's a quarter of a circle, so I'm going to have to divide that by 4, okay, because it's 1 quarter of it. I could also multiply it by a quarter, or I could divide by 4. If it was half a circle, I'd divide by 2. So pi times radius squared, the radius is 8. The radius is the line from the center to the outside. So pi times by 8 squared is 64 pi. And then obviously I need to divide that by 4. So 64 pi divided by 4 is 16 pi. Now, your calculator might come up with this. You can press SD, so the SD button, you can press that and then you get it in decimal form, but you don't need to. You can just leave it in terms of pi until the very end. So 16 pi is 50.26548,246. Okay, so the area of the sector, looks like we're not going to need that isosceles thing. The area of the sector is 50.26548,246. Now what we need to do is work out the area of the triangle. So how do we work out the area of a triangle? Well, we do base times height divided by 2. So we could just draw this triangle like that. And here we'd have 8 centimeters and here we'd have 8 centimeters. So base times the perpendicular height, that's why it's great that this is a right angle triangle, divided by 2. So area of the triangle would be base times height, 8 times 8 divided by 2, which is 64 divided by 2, which is 32 centimeters squared. That would also be centimeters squared. So area of triangle is 32 centimeters squared. And what I have to do is work out the area of the shaded segment. So what I've worked out with the sector is everything here. Then I've worked out the area of the triangle, which is 32. So I just do 50.265 take 32. So that would give me 18.26548,246. And it says give it to 3 significant figures. So I look at the 3rd digit. The number next to it is more than 5, so I round it up. So my final answer would be 18.3 centimeters squared because it's an area. Don't forget your units. So here I'm just sketching graphs. So for the first one, it's saying using the axes below, sketch a graph to represent y is directly proportional to x. Now what direct proportion means is that as one value increases, so does the other at the same rate. And it also means that if, like, one value is worth 0, so would the other value. So for instance, if a Mars bar cost, I don't know, back in my day it was like 25p, but now it's more like £1.15 maybe. So let's say one Mars bar cost £1.15, 2 would be £2.30, but 0 would be 0 pence. So if you don't have a Mars bar, you pay nothing. Okay, so direct proportion, it always goes through the origin, and the value increases steadily. So as one value increases, so does the other. So that would be a sketch of a direct proportion graph. Then I want to represent inverse proportion. So inverse proportion is the inverse of this. So it means as one value increases, the other decreases. So as one value gets larger, the other value will be smaller. So this is kind of what an inverse proportion graph looks like. It shouldn't touch the axes. That's just my pen. Let's do it again. Oops. Okay, so it's like this kind of thing. Okay, so that's inverse proportion. That's just a sketch of what a graph like that should look. So in this question, we're putting our knowledge of inverse proportion into action. So remember, inverse proportion is when one value increases, the other value decreases. So we're told that on Monday, 12 people took 5 hours to clean, and on Tuesday, 15 people cleaned the same number of cars. So remember, as one value increases, the other has to decrease. So if the number of people increased, the amount of time taken must decrease. So the first thing we do, obviously assuming that all people work at the same rate, because, you know, some people can be lazy. Now, the first thing we do is work out the total, human hours. I was going to say man hours just because everyone always talks about manpower and whatever, but human power. So total human hours worked is... Sorry, I had a little coughing fit. So total human hours worked would be 12 times 5, which is 60 hours. Okay, so work out how many hours 15 people took to clean the cars. So we know 60 hours are worked in total, and they're split between 15 people. So if we do 60 divided by 15, we should get 4. Let's just double check. Good. So 4 hours each. Okay, so the key thing here when you're dealing with inverse proportion, work out the total amount of like human power or whatever it is, like if it's boats, like boat power, the total amount of hours worked, and then you can split that between your new rate of people. However, it says the assumption is wrong. How might this affect the time taken for the people to clean the cars? So the assumption was that all people worked at the same rate. Well, if some people worked slower, then it would take a longer time. So it depends what you want to say, but you could just say if they worked slower, it could take more time. So in theory, it would be great if everyone worked at the same pace, but everyone is totally unique and different and has different skills and sets and specialities and talents. So probably the assumption is going to be wrong, but it's an average, isn't it? So yeah, if they took longer, it would take more time. If they were really quick, it would take less time. And that's okay, so here we've got a question showing a right angled triangle and another right angled triangle inside of it. This is generally going to mean that it is dealing with similar triangles. And the reason for this is because, well, to test if something's a similar triangle, you need to either have 2 equal angles, because obviously if 2 of them are equal, the third one's going to be equal. So either AAA, SAS, so side angle side, or SSS, but we don't need to worry about that. If you are more interested or you need a recap, watch the video on similar triangles. But for now, we know that these are similar triangles because they've both got a right angle and they both have this angle inside here. And obviously this angle will also be corresponding. So we're dealing with similar triangles. So in that case, what we want to do is just draw them out separately. So we've got this large triangle and then the smaller one here. So we've got A B, C, and then D, B, E. And we are told certain values of them. So A to D, okay, that's 9 centimeters. So that's just this bit here. D to E, okay, I thought they were going to be nice. They're not being super nice. D to E is 2 centimeters. So over here, 2 centimeters. And DB is 6 centimeters. Okay, so what we need to do is work out the side lengths of everything else. So I know that this is 6 centimeters. And I know that this is 9 centimeters. So therefore, I know the total length of A to B must be 9 plus 6, which is 15 centimeters. Okay, so it's just a little addition that we have to do. So I need to work out the scale factor of enlargement. So how do I get from shape, the large shape to the small shape? Well, 15 divided by 6 is 2.5. So this shape is 2.5 smaller than this one. So to get from the small shape to the large shape, I multiply by 2.5. And to get from the large shape to the small shape, I'm going to divide by 2.5. That's the scale factor of enlargement. That's how many times larger the large shape is. I need to calculate the length of CB, which is this long, I don't know why that always comes up. So this long bit over here. Okay, so in order to do that, I'm going to need to work out the side of EB. So how can I do that? Well, I can use Pythagoras. So Pythagoras is a squared plus b squared equals c squared. I've been given c squared. C is always the hypotenuse, the side opposite the right angle. So I'm going to just do c squared, take away a squared, must be b squared. Remember, a and b, it doesn't matter which one's which, they're both the shorter sides. So C is 6, so 6 squared, take 2 squared is going to give me b squared, which is this length here. So 36, take 4 is b squared, so b squared is 32. So b must be the square root of 32. So let's do the square root of 32 is 5.65654249. Okay, that's the length of B. Now I know that's 5.65 blah 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 blah. I know to get to the larger shape I need to increase it by a scale factor of 2, so I just multiply that by 2.5 and that gives me 14. So CB, let's do it in a different color. CB is 14.142136562, but it says give it to 2 decimal places. So CB would be 14. This is the second decimal place. I'll look next door, just 14.14. And that's your final answer. Okay, so here we're dealing with error intervals. Now, all an error interval means is if something's been rounded, then obviously it could be slightly higher than the value that's been given or slightly lower than the value that's been given. So let's have a look at 6.4. What could it have been rounded up to or down to? So she writes the value of x correct to 1 decimal place. So the decimal places around that would be 6.5 and 6.3. So the middle part is what we're interested in. So 6.35 and 6.45. Now, if it was 6.35, what would it round to? It would round up to 6.4. Okay, so 6.35, 6.36, 6.37, 6.399999. All of that would round to 6.4 to 1 decimal place. Where it gets a little bit trickier is over here. There's a lot of, 6.45 would obviously round up to 6.5. And that's why we use something called an error interval. So the lowest possible value that x could be is 6.35. And that's why we write that 6.35, and they've given this to you in the exam. I'm just writing it again. 6.35 is less than or equal to x. So x could be 6.35, it could be equal to it, or it could be more than that. But it has to be less than 6.45, because if it was actually 6.45, it would round up to 6.5. But it could be anything up to this value. So it could be 6.4, 9999999 going on until infinity. Okay, so that's what an error interval is. It captures everything, and it's important. This sign here is going to be less than or equal to, and this one here is just going to be less than, because it can't actually be 6.45, because then it would round up to 6.5. Okay, so here we've got a slightly tricky laws of indices question. So what we want to do is think of all the laws of indices, our index laws, and always have them in mind. So over here, I've got a to the power ax to the power of 6 to the power of a half n. Now, what do we do when we are dealing with indices in brackets? We always multiply the indices, don't we? So that would become a to the power of 1 over n, x to the power of 6 over n, and that equals 7x cubed. So all I've done is I've multiplied out my indices here. Remember, each part is going to be to the power, like if I said 6x squared. Oh, why has it gone large? Can you just not, please? So 6x squared to the power of 3. What I'd have to do, that would become 6 cubed and x to the power of 6. You have to, each little part is to the power of what's outside the bracket. That's why it's a to the power of 1 over n, x to the power of 6 over n. So now what we can do is compare. So we've got x cubed over here. So that must mean that 6 over n must be equal to 3. So 6 divided by what gives you 3? Well, 6 divided by 2 gives you 3. So therefore n must be 2. Okay. And then the bit that is a to the power of 1 over n must be this part here. So a to the power of 1 over n is equal to 7. So I know that a to the power of a half is equal to 7. So what that means is there needs to be a number. Let's get rid of some stuff here. Where can I do this? So a to the power of a half equals 7. So remember, this is what it's to the power of. And when you're dealing with fractional indices, that is what it's to the root of. So in this case, I need to think the square root of something. So something squared. So the square root of a is 7. Well, I happen to know that the square root of 49 is 7. So a would be 49. Okay, so here we have a fun coordinate question, and let's have a look at what's going on here. So a pattern is made from 4 identical rectangles. Keyword is identical, which means they're all going to be exactly the same. So their lengths, heights and widths are all going to be the same. The sides of the rectangles are parallel to the axes, which is great because it means we don't have to deal with any gradients. And then they tell us the point A and B, and we need to work out the coordinates of point C. Okay, well, in order to do that, I'm going to need to figure out what the height and the length of each rectangle is. So we're going to be dealing with algebra, so we may as well call them x and y. Oh, I hate it when it makes it big. Why have you made it big? Okay, x and y. Okay, so let's start by working out the x distance. So to get from point A to point B, so this distance here, this value here is 11, this value here is 3. That distance is 7. So the x distance between the points is 7. No, 8. 11 take away 3 is 8. And then the y distance is, so from 4 to 20 is 16. It actually probably would help if I label them the other way around, because then we're dealing with y is the vertical and x is the horizontal. Okay, so actually, I'm just going to label it height and length, just so that we don't get mixed up with variables and all of that. So how do I get from A to B? Well, there's a difference of 1, okay, and not quite 2 lengths. So it's 2 lengths, but minus a height, because this distance here is subtracted. So 2 lengths minus a height is my x distance, which is 8. And then my y distance, I go up by a height, up by a length, and up by another length. So 2 lengths plus a height is 16. Okay, so now I've got, and I've set myself up a pair of simultaneous equations, so I can solve these. So let's see what we want to do. Well, we always want to eliminate a variable, so I can either eliminate the L or the H. Let's eliminate the H because it's negative. So how would I eliminate negative H and a plus H? Well, let's imagine it was 2. Negative 2 plus 2 equals 0. So if I add the equations, I will eliminate. Okay, so therefore 2L plus 2L is 4L. Negative H plus H is going to eliminate. That's why I'm doing this. So that's 0. And 8 plus 16 is 24. So 4 lengths must be 24. So let's divide both sides by 4. And a length is 6. Okay, so a length is 6. And now I can just substitute into one of these equations to figure out my height. Oh, I've just deleted the equation, so I can't remember what were they. Was it 2L? Okay, I'll just work it out again. So it's 2L plus a height is 16. Okay, so we know that the length is 16, so we can substitute that value into here. So if one length is 6, 2 lengths will be 12. So 12 plus H is 16. H must be 4. Okay, so length is 6, the height is 4. So here's my little rectangle. 4 and 6. And I need to work out the coordinates of point C. Well, the coordinates of point C in terms of my y, which is so we start from 3, 4, that's x and y. I am going along the x-axis 6. Okay, so that coordinate will be 9. And then I know that the height is 4, so I'm going along 4. So 4 plus 4 is 8. Okay, so my coordinates are going to be 9, 8. Okay, so here we've got a ratio problem solving question. We're told that Olivia, Jessica have in total half as many sweets as Fran and Gary have. And then we're told their respective ratios. Okay, so what we want to do is say, okay, Fran and Gary, they have 2 to 3 parts. So they have 5 parts in total in terms of sweets. And then Olivia and Jessica, they share their sweets in the ratio 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 to 1. So that is in total 10 parts. Now, that's the minimum ratio that it can be. So we don't know exactly how many sweets Olivia and Jessica have, but we know that they need to at least have 10 because they're sharing it in the ratio of 9 to 1. So the minimum parts that we can have are 10. And we know that Fran and Gary have double. So they have double what Olivia and Jessica have. So if Olivia and Jessica have 10 parts, that must mean that Fran and Gary also need to have a minimum of 10 parts. So what we're going to need to do is multiply this ratio by 4. So their original ratio was 2 to 3. Multiply it by 4 would become 8 to 12 because that way they have 20 parts, yeah, which is double what Olivia and Jessica have. So because now they all have equal amounts of parts, and also in the correct ratio, i.e. that's double. So I could have just multiplied the ratio by 2 and they'd both have 10 parts, but I'm told that they have double what Olivia and Jessica have. That's why I needed to make it 20 parts, which is double. So now I can write their ratios out as Fran, W, X, Y, Z. That's the order I want to do it in. Gary to Olivia to Jessica. I'll just call her Jess. So Fran, oh gosh, I forgot where. So Fran was originally 2. He's going to be 8, or she, I don't know. Gary is 12. Olivia and Jessica still remain as 9 to 1. Okay, so the ratio W, X to Y to Z is going to be 8 to 12 to 9 to 1. Okay, so here I've been given a graph showing the volume of water from the moment it started to flow out of a container. Obviously, like when water starts to flow out, it's going to go woo, and then it's going to slow down a bit. So using the graph, work out an estimate for the rate at which the water is flowing out of the container when t is 12. So when the time is 12. So over here, that's going to be 15. So 12 is going to be over here. Okay, so when you're working out a rate of change from a graph that is not linear, what you need to do is draw yourself a tangent to the line. So this is annoying because I don't have a ruler, but I'm going to do the best I can. Okay, so you draw yourself a tangent to the line, and then what you do to work out, because gradient is just the rate of change, so what you do to work out the rate of change, you find the gradient of the tangent to the curve. Okay, so you draw yourself a tangent, which is just a straight line that touches the point at what the question is asking you. So it's saying work out an estimate for the rate when t is 12. So from you draw, like where your t is 12, you draw a straight line touching the curve. And then what we do is work out the gradient of this. Now I am going to have a really badly estimated thing because it's an iPad and it's electronic and I can't see very well. So well, let's work out the gradient. So I'm going to just do that here. So that'll be 10, 15, 6, so let's say 17. So the y-axis is 17. And I'm going to do it to 10. So 17 take 10. Remember the gradient, I'll do it in a different colour. The gradient is the change in the y-coordinates, or the difference in the y-coordinates over the difference in the x-coordinates. So my y-coordinates are 7. So the gradient is going to be 7 over, because from 17 to 10 is 7. And then from 12 to, I think, should I say 19? So 19 take 12 is also 7. Oh, I haven't done this well enough, have I? Well, I'm just going to say the rate of change is 1 litre per second. Okay, so I got really frustrated because it's really hard. As you can see, the line that I draw is really thick and it's difficult. So I did it on a piece of paper with the actual exam, and actually a litre per second would work, but depending on your tangent, anything between 0.7 to 1.1 would be absolutely fine. So, oh no, now I've just thrown my pencil away. There we go. Okay, so essentially that's how you do it. You work out the gradient, you draw the tangent, work out the gradient, and obviously you're going to have a pencil. It's going to be a lot finer, so it'll be absolutely fine. Okay, so over here we have 2 equations, one that is a curve and one that is a linear equation. So a quadratic like this. So remember, quadratics are just going to be curved like that, and the line L has equation. Okay, so it's a linear one, so, and they're saying it has only 1 point in common, so it's probably going to look something like that, and we need to prove that. Okay, so what we want to do first is rearrange this equation to make it equal to y. So y would be 5x take 4. If you're on question 16, you're probably quite good at rearranging, but if this is going too fast, then just watch the video on rearranging equations. Essentially, all I did is I added 5x to the side and then I subtracted 4, because to move anything from one side to the other, you do the inverse. So I've rearranged that equation, y equals 5x plus 4, and I've also got this one, y equals x squared plus 3x take 3. So what I want to do is make them equal to each other. So I know that y equals 5x take 4, so I'm going to substitute that into here. So 5x take 4 equals x squared plus 3x take 3. Now what I want to do is rearrange this whole thing and solve it. So x squared, I'm going to take 5x from both sides. So 3 take away 5 is negative 2x. And then I'm going to add 4 to both sides. So negative 3 plus 4 is positive 1, must equal 0. Okay. So I've got my equation here. And now what I want to do is factorize it to find its roots. So it's a quadratic. So the factors of 1 are 1 and 1, and they need to make negative 2x. So negative 1 times by negative 1 makes positive 1, and negative 1 take 1 is negative 2. So they're both going to be x take 1 equals 0. So when it comes to solving it, well, I can divide one at a time. So x would be 1, and then do the same on the other side. X equals 1. So I've shown algebraically that C and L have exactly one point in common, because the only point at which they touch is when x equals 1. There's only one root because it's the same thing. Okay, so that's how we do that. Okay, so here we've got a statement, a proportionality question. So what we can do is start off by just writing our statements of proportionality. So x is directly proportional to the square of y, so y squared, and y is directly proportional to the cube of z, so z cubed. Now, when we're doing our statements of proportionality, we know that that's proportional, but what that means is that it's multiplied by something. So that's why we'd say x equals k y squared, and y equals, I mean, normally we'd say k, but because there's two of them, let's just say y cubed. Okay, so if this isn't making too much sense, then watch my video on direct proportion. It goes through all of this at a much slower pace. So I've got my two equations here. Now, this question is tricky because it involves two equations. So normally when there's two equations, what you're going to want to do is substitute one into the other. So as you can see, we have a y here and we have a y here. So what we can do, we know that y equals sorry, that's supposed to say z. We know that y equals a z cubed. So we can substitute that into this equation. So x equals k a z cubed squared. Okay, so now we've got this nice looking equation that we can solve. So first of all, what we might want to do, and the reason I'm putting them together is because I know that z is 2 when x is 32. Well, that they're two separate equations, so I'm going to have to figure out how to combine them. The way to combine them is substituting part of one, well, the whole of one into part of the other. Okay, so x would be, should I expand it all first? Yeah, so k a squared, and then is that a z? Z to the power of 6. Okay, so now I can substitute the information that I've been given. When z is 2, when x is 32. So 32 equals k a squared z to the power of 6. So 2 to the power of 6. Oh, where's my calculated one? I should be able to work this out in my head, but I'm tired. So 2 to the power of 6 is 64. That's embarrassing. Okay, so 32 equals ka squared 64. I need to find a formula for x in terms of z. So that means I need to get it in the form x equals. So when it's say in terms of, the in terms of stuff has to be on this side. So it needs to be in terms of z. So let's figure out what I can from here. So 32 divided by 64 would be 1/2 equals ka squared. So ka squared equals 1/2, okay? So once again, think about what we can substitute in. So 1/2 equals ka squared. So where's my equation? My original equation is over here. And I figured out that ka squared is 1/2. So I could just say x equals 1/2 z to the power of 6. And that's it. That's your final answer. That's how you could write it. Or you could say x equals z to the power of 6 over 2, because obviously they're the same thing. But that's how you'd find a formula for x in terms of z. The tricky part here is realizing that you have two equations, so you can substitute them into each other and just jiggle things around. Okay, so here we've got a vectors question. Now, the thing that catches most people out with vectors question isn't actually the vector part, it's the fraction part. So if this question is a bit tricky, I can almost like 98% guarantee it's not the vectors that are confusing you, it is the fractions. So really get hot on your fractions, understand them really well. And ratio too. Okay, so OABC is a trapezium. We're told that OA is A, AB is B, and OC is 3B. So they're the roots that we've been given and the roots we're going to have to take. We can only take roots that we've been given. And we know that D is on the point such that OD to DB is 2 to 3. So this is important. So OB is a line, and O to D is going to be 2/5 of that line, and D to B is going to be 3/5 of that line. So over here, that would be 2/5 OB, and D to B would be, is that right? O to D is 2/5, yep, and that would be 3/5 OB, okay? So similarly, on this line here, we've got BE, E to C is 1 to 4, so that would be 1/5 and 4/5. So BE would be 1/5 of BC, and EC would be 4/5 of BC. So we've got that all done. What we want to do is work out the vector DE, so this part here, in terms of A and B, and give your answer in its simplest form. Okay, so that's obviously a little bit of a tricky root. So we're going to think about the roots that we already know. So we're dealing with the lines OB and BC because they're the ratios that we've been given. So first things first, let's work out what OB is. So to work out a vector, you can only go along your given roots. So we've been given this, oh no, don't delete. So we've been given this root here, which is A, and this root here, which is B. So the vector OB can be expressed as A plus B. Okay, so that's the whole line OB. Now, I know that the part DB must be 3/5 of that, because it's 3/5 of the whole line. So 3/5 A plus B is vector DB. Now, similarly, the other line that I've been given is BC. So how can I work out the vector BC? Well, once again, I have to go along my given roots. And what's important is that if you're going in the reverse, so this is the vector B, but if you're going in the reverse direction, it's going to be the negative. Okay, so I'm going in the reverse direction. So it would be negative B to go along here, negative A plus 3B. Okay, so let's simplify that. That would be 2B, take A, and I already know that B to E, so B to E is 1/5 of B to C, so that would be 1/5 Is that right? Yeah, 1/5 to B take A. So let's simplify that. So BE would be 1/5 times 2 is 2/5 B. Take 1/5 A. And similarly, we can expand this one here. So DB is 3/5 A plus 3/5 B. Now, I'm just going to write these here. DB is 3/5 A plus 3/5 B. I'm just going to get rid of all this working to make space. So I've got those vectors. And the reason I worked that out is because that's one of the roots. Let's delete everything off here too so we can see the roots and how everything's happening. To work out DE, why does it always make it so large? I just want a nice thin line, please. There we go. So DE, how can I get from D to E? Well, I can go from D to B and then B to E. I could also have done this. I could have gone D to O and that way and that way. That's absolutely fine if you want to do that way. You just would have worked out the opposite, so 2/5 and then 4/5, I think it was. It doesn't matter which way as long as you're just going along the designated route. Anyway, let's stick with the route that I chose. So D to E is DB plus BE, and that would be, so DB is 3/5 A plus 3/5 B, and BE is 2/5 B take 1/5 A. So this is why I said fractions are really important. So let's simplify this. So 3/5 A take 1/5 A is going to be 2/5 A, and 3/5 B plus 2/5 B. Well, 3/5 plus 2/5 is just 5/5, which is 1. So that's just going to be B. And that's your final answer. So DE in its simplest form is 2/5 A plus B. Let's just highlight that. Okay, so in this question, we are dealing with population growth. So, well, in this case, population decline. Oh, that's really sad. At the start of the year, the number of animals in a population is Pn. Oh no. Well, I mean, it's kind of what happens. That's actually made me sad. Okay, anyway, so at the start of the following year, the number of the animals in the population is Pn plus 1. Okay, so essentially we've got here the population in 2017 is 4,000. Okay, the population in 2018 is going to be K times Pn. So Pn is like the original population, the OG. Okay, so K times 4,000.
Sorry, I didn't get that. Could you restate the question?
I don't know why they're getting involved. Okay, and then the population in 2019 is going to be...
I found this on the web for OK, and then the population in 2019. Check it out.
Do I tell it to... Okay, Siri, turn off... I don't know why it's on. Okay, so... Please don't start talking. Okay, so the population in 2019, remember, it's always K times Pn. So it's the year prior to that. Basically, Pn is the original year, and each time you add a year on, you're multiplying by the previous population. So if the population in 2018 was K times 4,000, the population in 2019 will be K times by K times 4,000, right? Because that's the population in 2018. So I know that at the start of 2019, the number of animals, it was 3,610. So 3,610 is K squared times by 4,000. Now all I need to do is find the value of the constant k, and I do this by just solving. So 3,610 divided by 4,000 equals k squared. So therefore, type that into your calculator. K squared is 0.9025. How do I work out k? I'm going to have to square root both sides. So the k is the square root of 0.9025, which is 0.95. Okay, so apologies from the interruption from Siri. Hopefully it doesn't turn on again. And that's how we'd work that question out. Okay, so here we've got a probability question. We are told that Pat throws a fair coin n times, and we need to find an expression in terms of n for the probability that Pat gets at least one head and at least one tail. Okay, so the probability of at least one head and one tail. So how would I work that out? Well, all probability sums to 1, so it's going to be 1, take away the possibilities of this happening. So to get at least one head, I would need the probability of getting heads all the time. So the probability of all heads, and take the probability of also getting all tails. So how could I work that out? Well, I know that the probability of getting a head at any given time is a half, same as the tail. Probability of then getting a head, tail is a half and a half and a half and a half. Okay, so let's see at what's happening. So if I were to throw the coin twice, probability of getting all heads would be a quarter, and similarly the probability of getting all tails would be a quarter. So for throwing it twice, the original is a half and it turns into a quarter. Let's see what happens when I throw it 3 times. So continue my little tree: head, tail, head, tail, head, tail, head, tail. So getting 3 heads would be a half times a half times a half, which is an eighth. And getting all tails would be a half times a half times a half, which is also an eighth. So 3 times would be an eighth. Now I'm just going to get rid of this tray diagram because hopefully by now you see the point of it. If I did it with 4 throws, I would do a half times a half times a half times a half. So that would be 2 times 2 is 4 times 2 is 8 is a 16th. Okay, so for 4 throws, it's a 16th. So what's happening is the probability depends on how many times you throw the dice. So the probability of getting at least one head and one tail would be 1 take away. Probability of all heads is a half, but it's independent on how many times you throw it. So if you throw it 2 times, so let me just show you, I'm explaining this really badly. But so if n was 2, you would do a half times a half, which is a quarter. If n was 3, you would do a half times a half times a half, which is an eighth. Okay, so however many times you throw it is however many times you multiply getting a head. And the same thing for the tails. So that would be a half n. Okay, so the expression would just be 1 take away a half to the power of n, take away a half to the power of n. Okay, so here we've got a question speed time graph, and it's asking us to work out an estimate for the area under the graph. Now, just a quick one, area under a graph represents a distance travelled. So speed, time, and the area underneath is the distance travelled. So we are asked to use 3 trapeziums, that's nice that they've told us to how many, of equal width to work out an estimate for the area under the graph between t is 1 and t is 4. Okay, so over here and over here. Well, there's a difference that can split nicely into 3 just like that. The reason I say trapeziums is because obviously we can work out the area of a trapezium a lot easier than we can that curve thing. So what's the formula for the area of a trapezium? Well, the formula for the area of the trapezium is a plus b times by h divided by 2, where a and b are the 2 parallel sides, h is the height. So for the first trapezium, we've got a side of 4 and a side of 6, and the height is just 1. So we're going to do 4 plus 6 times by 1, which is 10. 10 divided by 2 is 5. So the area is 5. And we do the same for the next one. So that's, let's just change the numbers. It's a height of side of 6 and a side of, oh, what's that? I would say that's 7.1. Where's my calculator gone? So 6 plus 7.1 times by the height, which is 1, divided by 2, which is 6.55. So 6.55. And then again, so is that 7.1? Yeah, do you know what? Let me just delete this so that I can see it better. I'm going to say that's 7.2 actually. So let's hold my breath. I take it back. Let's undo that. Oh my God, why does it undo everything? So that's 7.2. Let's just do this properly. 6 plus 7.2 divided by 2 is 6.6. Okay, so that's 6.6. And then the next one is going to have a height of 7.2. And then this, let me just delete the line so I can see it properly. So that would be 7. It's going up in 2. So 2, 4, 6, 8. 7.8. Okay, so 7.2 plus 7.8 is 15 times 1 divided by 2 is 7.5. 7.5. Let's just fill this back in. Okay, so work out an estimate for the area of the graph. Well, 5 plus 6.6 plus 7.5 equals, plus 6.6 plus 5 equals 19.1. Okay, so be really careful. I've obviously got this fat like pencil, so it's tricky, but yeah, they're all going up in 0.2s. And what does this area represent? Well, like I said at the beginning, the area under the graph just represents the distance travelled. Okay, so the total distance travelled. Okay, so here we are approaching the end of the paper, are dividing algebraic questions, fractions questions. So it's at the end of the paper. It's going to be slightly tricky, but let's have a look at what we can do. Well, the first thing I'm noticing is that over here, I've got the difference of 2 squares, okay? So what I know I can do is factorise that. So I'd have 6x cubed. Why does it do this? Honestly, if anyone understands why it suddenly changes to really thick, please let me know in the comments so that I can fix it. Okay, 6x cubed. Now, the difference of 2 squares means that it's going to be, if I factorised it, it would be 3x take 12 and 3x plus 12. Okay, and that's being divided by 2x to the power 4 times 3x to the blah, blah, blah. Now, what do we do when we divide fractions? Well, let's say I was doing 2/3 divided by a half. All I would do, keep the first fraction as it is, change the sign to a multiply and flip the end fraction. I call it the KCF, the cheap version of KFC. So I have to do the same thing here. I am going to keep the first fraction as it is. Of course, I factorised it to make life easier for myself, and then multiply it by 3 brackets x take 4 to the power of 2x to the power of 4. So when I'm multiplying algebraic fractions, essentially, or dividing or manipulating or anything, essentially what I want to do is find a part on the denominator that is the same as a part on the numerator so that it can cancel out. Now, what I can see is that over here, I've got 3x take 4. Over here, I've got these brackets, but I know I can factorise them further. So I could turn that into 6x cubed over, and if I took the 3 out, that would become x take 4. And then this one would be 3x plus 4. Okay, so now I can do a little bit of manipulation. Let me just get rid of that thing. I don't know why I put that there. So remember, when you've got fractions, anything that's on the numerator that is also on the denominator, when they're being multiplied, can cancel out. So 3x take 4 is going to cancel out with this. So then I've got a much nicer fraction to deal with. So I've got 6x cubed over what can I do? So I've got 3 times by x plus 4 times by 2 times by x to the power of 4. So what can I do? I know I want to get this to be 1, so I essentially have to find out 6x cubed. So I could simplify this to be 6. So that would be 6x cubed over 6 times by x to the power of 4 times by x plus 4. So the 6 and the 6 would cancel out. So I'd be left with x cubed divided by x to the power of 4. Now, if I just think about it, x cubed just means this. X to the power of 4 just means this. So that and that, that and that, that and that would cancel out. So I'd just be left with x on the bottom. So that can cancel with that. And I'd be left with 1 at the top and x here, x plus 4. Once again, I have no clue why it's turned into a really large stroke. But what can you do? So that's how I'd do that question. The whole point is finding things that you can cancel out. And yeah, there we go. We've got it in the form where r is an integer and the value of r is 4. Hello and well done. Congratulations, you've made it to the final question of this GCSE paper. So over here, we're going to look at proofs. And the whole point of proof is that you're not trying to solve something, you're not trying to figure the value of something out, you're just trying to show your steps of working that get you to a certain line of reasoning. So we're told that we've got a triangle, it's obviously non-right angled, so we're going to use either the sine rule or the cosine rule. Now, but we're being asked to prove that AB over BD is AC over DC, so it makes sense to use the sine rule because that's already in that form. So sine rule is A over sine A equals B over sine B equals C over sine C. Now, just to recap, A is obviously the length of the side, and a capital A indicates an angle. Okay, so what we want to do is start with AB, the side that we are given. So AB over sine. Now, the opposite angle to this would be over here, so that would be ADB must be equal to the other sides that we've been given is BD. Oh no, I didn't want it to delete it. Oh well. BD, and this is the angle of BD, so that would be BD over sine X. This is for triangle ABD. Okay, let's do the same for triangle ADC. So AC, let's do it in a different colour. AC is this angle here over, and this is its opposite angle, so angle sine ADC equals, and then DC is over here, and its opposite angle is over here, so that would be over sine X. So now I've got this, what I can do is manipulate these equations a bit. So let's cross multiply, so AB sine X must be equal to BD sine ADB. And then what can I do? Well, I could divide both sides by BD, so AB over BD must equal sine, and then divide both sides by sine X, sine ADB over sine X. And let's do a similar thing over here. So multiply both sides by sine X, AC sine X must be, and then both sides by sine ADC, DC sine ADC. And let's divide both sides by DC. So AC over DC is sine ADC over sine X. Now what we have here is, if you can see, we've got what we started out with, so AB and AC. So if AB and AC are equal, that must mean that sine ADB and over sine X and sine ADC over sine X must also be equal. So if you're following along and you're writing this down, screenshot this or write it down on pause, because I'm going to delete it. So I'm just going to write out the key part. So AB over BD is sine ADB over sine X, and then AC over DC is sine ADC over sine X. Okay, so I'm just going to get rid of all of this to make space for some working. And then let's see what I can do now. So I need to prove that AB over BD equals AC over DC, and I do this by proving that these two are equal. So sine ADB over sine X is equal to sine ADC over sine X. Well, they're both being divided by sine X, aren't they? So like if I said to you, I don't know, n over 5 equals n over 5, they're both being divided by 5, so therefore n must equal n. So by the same logic, sine ADB must equal sine ADC. So if that's the case, if sine ADC equals sine ADC, therefore AB over BD must equal AC over DC. And that's how you prove that. So thank you very much for watching. I hope this was helpful. And if you have any suggestions or any topics that you want me to go through individually, then just drop a comment below and I'll do that as quick as I can.